Okay. Hello, this is Xander Cesari with the Rust project content team. We're recording here at RustConf 2025, and we just watched an absolute rip-roaring talk from Yuri here, talking about Rust adoption at Rivian. So, Yuri, if you just want to kind of talk about your history, maybe in technology, from Map Libre to Rivian, and maybe where Rust got involved along that journey.
And thanks for the kind words. Basically, I'm mostly an open source developer. Started as a Wikipedia contributor, as an contributing to the engine of Wikipedia many years ago. Became one of the biggest code contributors to that. Then got hired by Wikipedia, and while at there, built some mapping software that got used by Elasticsearch, which hired me to because it's much easier when someone maintains it who built it, and that's the whole idea of open source. And so I worked for Elastic for like 5 years, and while at Elastic, I co-founded Map Libre, which became a very attractive point to Rivian, and they hired me to continue on that journey. And what little did they know that I became a Rust fan by that time. And they're like, oh my God, now you're not only doing the map and data and all that stuff and visualization stacks, it's now a Rust fan who is promoting Rust everywhere at Rivian. So that's where I am now.
Yeah. So Map Libre, it seems like there's some Rust in there. Is there kind of like a core Rust performance engine around?
So Map Libre is it's a couple of things. One is it's a nonprofit organization that runs a bits to pixels aspect. In other words, you get also some data somewhere, and then you render it, and in the process, you also have to serve it. In the serving ecosystem, there's a service called Martin, which I basically maintained for the past multiple years and wrote quite a lot of code in, is the fastest Rust tile server implementation that helps make maps appear really rapidly on the screen. Now there's other tools, like there's a native C++ and the WebGL written in TypeScript that render the maps really rapidly. MapLibre started as a fork of Mapbox due to license changes, but now it grew to a much bigger and almost ubiquitous stack. Microsoft Bing Maps, Lyft, AWS, Facebook. I mean, pretty much everyone is using it one way or the other for various map rendering needs, and that's where we're at.
It's a story of the triumph of open source, right?
Basically, yes. And I'm very happy that it's gotten to this point. It has significant both corporate and individual support, lots of volunteer contributions, a lot of corporate contributions, code contributions, financial contributions. And yes, it succeeded. And I feel the most important reason for this is it became a community governance rather than a hero type of project, which has much less of a dedication, lifespan, determinism. So very happy it succeeded as an organizational effort to get the community really moving forward.
So from open source, where you can implement new technologies and you can kind of move fast, all the way into automotive, which is famously a very difficult place to implement new technologies.
Maybe that's why I like Rivian so much. We have much less of a legacy, and we can innovate much more rapidly.
Yeah. I mean, what do you think makes implementing new technologies anywhere in automotive so much harder than it seems like it should be?
Oof.
And this is not just Rivian. I don't mean to, this is a problem of all the automakers. It's just the context of the industry, right?
I think, there's many things. And one of them is cars are very safety critical devices. You don't want your brakes to fail. You don't want many other subsystems to fail either. And the reliability of the vehicle is extremely important. As such, there's all these certification processes that became standard in the industry. And yet, when a new technology such as Rust evolves and develops, you don't have the same check marks that have been established for other languages, simply because you don't really know what they are yet. What are the common pitfalls? With C, you know there's all these giant lists of issues you could have. And so you kind of mitigate them by writing out, you are not supposed to do this, you're not supposed to do that. Whereas in Rust, well, compiler already takes care of like 70, 80% of all those. So now you have to figure out the new list, which is going to be probably much shorter, hopefully. And at the same time, it might be new. It might have new things. And if no one really took the effort to draft that list and come up with the things, it becomes so much harder to prove to the management. It's like, well, yes, we're risking on one hand. On the other hand, this technology itself precludes all these issues, and it could be so much more like safer and more stable and bug-free by nature of the tooling itself.
Yeah.
That's always a challenge, and it's a process that has to be resolved.
Yeah, I mean, legacy code bases come with certain guarantees once they've been running for
especially that
decades, and it seems like Rust is kind of bringing those guarantees through the compiler instead of just through battle-hardened code.
Exactly.
Yeah.
And in automotive space, very often you do write new code, but as long as you adhere to these expectations and standardization certification processes, you have this possibly misguided feel of safety. And the reason I say it's misguided is because the real judge of quality is not if you have checked some checkbox somewhere, it's whether you crashed or not per mile. Mm-hmm. And I mean, ideally you should have both, the check mark and a lack of crashes. But we shouldn't substitute one for the other. And when Rust gives us the opportunity to just, the moment it compiles, it runs, it's a very appealing proposition, but we still may need some checkboxes to at least pacify those who haven't had experience with it yet.
Yeah. So you just gave this great talk about the cultural Rust adoption at Rivian. And one of the things that you said is that there's a lot of buy-in at the highest level of management, that the CEO and the CTO are really interested in Rust. What won them over? What made them excited about this technology?
As I said in the talk, it's a lot of, well, not nagging essentially, but repeating the same message over and over until it reaches the right ears, and showing some results that are very successful.
And they're seeing product level results. They're seeing products that are safer, products that are cheaper to develop, or
feedback from other companies is extremely useful.
Okay.
When the CTO of Microsoft mentions repeatedly that, look at all these amazing things we've achieved, other companies start paying attention. They're like, oh, wait a second. We also want that same thing. It is very appealing, especially if you say, look, you compile and, as we call it, shifted left. In other words, you shifted all these bug detection to the compiler time, not the after compile trying to catch things that already got past the compiler. And that became a very compelling story. And as far as social, I mean, all of these are social aspects, and social aspects, surprisingly, are extremely important and very hard for many developers to achieve. We are very good with technology. We can solve all sorts of really crazy, complicated problems. What very often we lack the skill of is communicating those benefits to those who might be less technical, or technical but more in the management aspect. And yet those are the way we can really prove our point and get to the new and exciting capabilities. At Rivian, well, technically it's Rivian Volkswagen Technology Group, which is a joint venture with Volkswagen, where we're now hoping to influence Volkswagen as well. Yep. The technology, Rust is vastly popular among individual grassroots developers.
Right.
So at least those who have experienced Rust, those who are sick and tired of debugging things in production. Not the best thing, not the best time to debug things. When you make it to production, it shouldn't be buggy. And upper management now sees the benefit especially top management says, yes, we want that. We see the results, especially from other companies, saying that you can do significantly faster development and much less buggy. And then you have to actually apply it to specific projects. And that's when the problem comes. Because now, in theory, it's great, but we have this giant legacy code that needs to be maintained. And there's one more feature that's needed in this stack. Do you want to start a new project in a completely new language and not sure how to integrate it with the existing ecosystem, or you just add a few lines of C++ code? And that's where the uncertainty comes from, because if you start it as a new project, even if it's a standalone binary that runs by itself, project managers who are uncertain of the timeline because they haven't experienced it are somewhat uneasy about this. But in theory, yes, but in reality, we have had this experience, and most importantly, we have all these experienced developers who know the stack, who know the CI, who know how to build good software in the existing ecosystem. So that barrier of adoption is probably the hardest, because you have to communicate with everyone in this chain to really convince people, and also you have to do a lot of legwork in terms of building the tooling. Cofounder is a great example. It's a way to run Crates.io inside the company, so the code can be easily and efficiently shared, versioned code, between various teams. Proper CI/CD templates that take care of the CMake, Bazel integration, other things, all the wrappings for the existing C++ libraries with expert Rust, FFI Rust experts, building their proper wrappers so that Rust novice developers do not sprinkle unsafe everywhere, which is a very common thing, because C++ developers are like, well, it's just a pointer. What's the big deal? I'll just write unsafe. No, you have to explain. No, you want to contain unsafe in a very small layer right over the C++ code, and then no unsafe allowed. So all this education and all this tooling and all this wrapping has to be built by someone, and that adds to the uncertainty of the project timeline that has to be resolved.
Yeah, I mean, I think those are difficult things to invest in, that infrastructure level, because it's not really tied to any one specific small project. So someone somewhere in the organization has to say, we need to spend some time and money building up this internal infrastructure.
Exactly. And that's why the whole explanation also has to take into account a separate thing. Start slow. It's okay to start slow, because you'll speed up later to a much greater extent.
Yeah.
Those rockets that launch to space, they usually move really slowly to get to the launch pad, and then they take off.
Right.
So start slowly, adopt the new technology, because the end result has been shown time and time again to be much better in the long-term thing. Because, the bugs are exponentially more expensive after the compiler than before. So the more you can shift to the compiler, the faster overall product is.
Yeah. Well, in automotive especially, there's long been this idea of making your changes as early as you possibly can. In hardware, that means make your changes in the design phase instead of retooling the factory. And even in software, the ability to do, I know that Rivian is actually one of really the market leaders in OTA, but it's still more difficult to push OTA after the product is in the field than it is to catch it early.
Yeah, chips usually don't rewire themselves once
you can't do hardware OTA.
Yes. We're still working on that.
Someone will solve it.
Yes.
Zonal architectures.
Exactly.
One thing you mentioned explicitly in your talk, and I think you kind of talked around in that answer, is this issue that the grassroots developers, the working engineers love Rust, the C-suite loves Rust. It is that middle management layer that's maybe a little bit more dubious, and maybe the CTO is thinking about, I can take this 4-year development cycle to a 3.75-year development cycle, and they see the millions of dollars.
Or 2-year. Well, that's the idea.
But it's the middle manager who has to say, look, I don't have the time to tool up a new build system or a new dependency management.
Just uncertainty of unknowns. Which unknowns do I not know?
Yeah.
And those unknowns of unknowns is the hard part.
Yeah.
Because when you develop things in a well-known system, the only thing you have is I forgot the name of the guy who about time expectancy for the project, and you have to basically double it, and it's always double. But at least you can predict approximately how long something will take. The moment you do it in a new ecosystem without knowing the dependency time frame, then it becomes more uncertain, and that uncertainty is what project managers are somewhat concerned about. And I cannot blame them. Their responsibility is to ship. Engineers never ship. Project managers ship yesterday. So you have to balance these things.
Yeah. And it sounded like you had some really good tips for the right places to start Rust in the organization. Yes. I think you mentioned internal tooling and some other good areas.
So my things that do not work, let's start with that, is internal meetups, I call them. Basically, people get together and talk Rust, discuss how Rust is awesome, doing Rust quizzes, doing the Rust learnings.
And that did not work.
It did not work for one very simple reason. Learning without applicability is fun, but kind of pointless. You have to apply your knowledge to something. So the very first thing in a corporate environment that you need to do is come up with some deliverables, something to actually apply your knowledge to. Once you have those deliverables, you also can dedicate a team of excited engineers. Usually works with junior developers quite well, senior developers, some work, some might not work so well, but the more excitement there is, the better, and those engineers will attempt to do those deliverables, and more importantly, they'll communicate between themselves and review each other's code, hopefully under the guidance of someone who actually understands Rust, in teaching good patterns, good design decisions, while also building some basic missing tooling that fits within the organizational ecosystem, CI/CD templates, shared code, etc. And then these, we call them tiger teams, can proliferate the knowledge in their corresponding teams. And also, if the team is made from multiple different subgroups, they can collaborate with each other much better. So there's a lot of cross-team communication, cross-team code sharing happening, cross-team knowledge transfer, plus more easily reviewed code. Like you can ask some other team members from other teams to review your code and give some feedback on. And all of these things really help grow the Rust adoption.
Yeah, I think that was a really interesting point, because for so many people, the instinctive first step is, let's be social about it. Let's start a meetup. You want to hang out and talk with other Rust stations, but something about not having that deliverable, that action item, just means that sounds like it never really turns into anything.
We had tons of fun, don't get me wrong. There's nothing wrong with meetups, but if you cannot apply it to anything,
so if you can find
your meetup starts shrinking, because people have other things to do, and it turns into like a lunch and learn type of thing, like dinner in the movie. You're sitting, you're watching someone talk about Rust while munching on something. Okay, but then you forget it the next day, or even in a few hours when you have some C++ work to do.
So you were able to find kind of internal needs, maybe a tool or a process that could be improved, and then you can jump right into the action item. That's also interesting, because so many people say, I want to learn Rust, but I can't just read the book. I need a project to do. And you're just like, exactly. That's true for an individual, and it's true for an organization.
Yes.
Yeah. Okay. I think that's a great tip for anyone who's interested in bringing Rust to their organization.
And interestingly enough, even if you had designated a team to learn Rust with the expectation of the team coming up with the deliverables, that also works.
Okay, sure.
So you don't have to start with the deliverables. You have to start with those who are given resources, time, and expectations of delivering something in Rust. And you can kind of be very loose about it, because the team could come up with some CLI tools. You teach them about clap, they're like, oh my God, you can parse CLI tool, command line arguments by using clap derive. And then it just works. And that's like instantly tons of code written with like very safe and easy to use way. And then they start building on top of it and actually building some basic tooling, which could have done in Python. But the maintenance of that
Yeah.
might have been much more expensive in the long run, especially as it grows beyond the half a page of code.
Yeah, this is kind of that inverted difficulty curve of Rust, where
Exactly.
it's difficult to get Hello World running compared to Python, but then doing a whole CLI tool is shockingly easy, and all of a sudden it just works.
Actually, I would say easier than in Python in some cases. Well,
Yeah.
depends how. At least like in stability and reliability sense.
One other interesting point you made that I think a lot of people might be surprised about is that you felt that embedded is actually a difficult place to start Rust. Is that really in the automotive context?
It's slightly more difficult than having operating. I mean, well, no standard library development is by definition harder than standard library development.
Mm-hmm.
If you write main function, that's by definition much easier than creating a padding handler as the very first thing.
Sure.
So that said, in the embedded world, you usually have a lot of existing code, and then you with the firmware that has a operating system running, you sometimes can get away with running a completely separate new process that has just some usage of messaging pipeline to communicate with other processes. And if someone wraps that messaging pipeline with proper Rust wrappers, you're Rust safe, no one safe everywhere. And that's a very easy way to get started. Whereas if it's embedded, it's all quote unquote one process.
Yeah.
And then you have to deal with all the existing ecosystem. And then the whole existing ecosystem is usually in C, which is very good because bindgen really helps. But at the same time, it has a lot of expectations of how things are done. Global variables. We do not like to pass function parameters because stack is very sparse and very small. We want to limit it as much as possible. And this leads to a very different design paradigm if you're doing a little plugin. Mm-hmm. It's doable. It's totally doable, but a lot of Rust goodies are missing from that picture.
Yeah.
You don't have memory allocation. You cannot use all the vectors and other things. So you kind of have to force your way into this ecosystem, and it's not as straightforward as writing your own standalone process.
Yeah, and I think you mentioned a couple of other things about dependency management in Rust being just a little bit different than C and some of the build tooling.
Yes.
And a lot of that isn't less that C or Rust is right or wrong, but just that people have this way of doing things. They want to bring that to Rust, and they're not going to have a good time translating that mental model. You almost need to generate a hard reset.
Yes, and this applies to pretty much every language. Whenever someone starts writing Rust, you usually could kind of guess which language they're coming from because they try to fit that mental model they had that they've been trained for in their old language into Rust, and it never fits.
Yeah.
Because every language is different. Every pattern, every language has its own approaches to doing things. Go has one style of error handling. C++ has a different style of error handling, etc. Object-oriented versus kind of like basically just calling procedural approaches versus functional languages, yet another completely different thing. So the developers have to be taught how to do it properly in Rust, and that applies to pretty much migration to every language.
Sure.
But some of the interesting things is, you're right, that C++ developers, the whole packages, dependencies are kind of foreign. I mean, it's making its way into C++ world, but you usually just vendor the code from the external repos, and you just maintain the copy-paste of the code, which gives you stability of that code, but does not offer a lot of like bug fixes and other things. And then you're basically the response over this giant code ball, tarball of code. Mm-hmm. At the same time, if you're coming from Java, there's like everything is an object. And it has to be an object. And I want dynamic everywhere. And like, why? Like, you can just call the function directly or even just do a standalone function. No. Everything has to be part of an object. So there's other things. Plus, warnings. I love warnings. I love seeing warnings in C++ code. There's like, you compile it, and 200 warnings, it's okay. It works. Don't worry about it. And then you have to explain, no, if Rust complains, that's
Yeah.
not okay. Fix it. Make it part of the CI requirement that no warnings are passed through. One other thing, like something I've discovered to be very useful is just files. I haven't talked about it in my talk, but just files are awesome because they're much cleaner replacement for the make files. And just files allow you very easy way of making the same instruction, the same steps to run in CI and locally.
Okay.
Except that just file could detect if it's CI or not CI, and then you can say, if it's running in CI, there's D warning, treat warnings as errors. And if it's not, exactly the same commands run, but without that flag, and then you can do proper development without maintaining your code perfectly warning-free while developing, because that would be a very massive pain to do. So doing this style of development, where CI enforces no warnings, good style code, formatting, clippy, pedantic clippy, the more pedantic, the better. Especially clippy is amazing as an education tool. Sidelining here, but when you're teaching Rust to folks, I had an intern, and the intern wrote amazing Python complex code to do some very complicated image processing. And then I'm like, well, we cannot really put it in production as a service, as a cloud service. And then like, could you rewrite it in Rust? And with the AI help, it was done in 1 week. Without that person actually knowing Rust.
Yeah.
And then like, I told him like, well, here's the CI steps you should add, like clippy, format, whatever. And then it took them an extra week to get through all of these warnings and styling issues, but it allowed them to really understand quite a few concepts that were missing from the AI because they did not understand those. And that was a great learning opportunity.
Yeah.
So, but yes, adapting to the language is possible and doable.
Yeah, well, it sounds like something you mentioned earlier, setting up the CI/CD and the procedure and the tooling at an organizational level, so that when someone does go into a Rust project, they have that, the rails are greased for them.
Exactly.
All the tools are set up, and they're going to get taught kind of the right way.
Yeah.
Yeah, that sounds like it would really help adoption.
And obviously, do not start Rust as like getting a whole bunch of C developers sitting down at the table. It's like, let's do Rust. And everyone just switches to Rust, and none of them have any skill in Rust. The results are not going to be that great. You need someone to at least glance at your code once in a while to say, no, you're doing this wrong and this wrong, simply because you're trying to fit something, a mental model that shouldn't be done that way. Even those occasional reviews of the code would greatly help this C, C++, Java, whatever developers get started.
Yeah. Do you find when you sit down with someone who knows a different language really well that you've now figured out how to teach them, okay, I know that this is your mental model, and I'm gonna, let's cross these things out, and these things get transitioned over here, and then you talk with someone else who knows a different language, and you're like, okay, you have this mental model, and we're gonna start there.
Giant table, like, if you do this, do that instead.
Yeah, I mean, I think if you've only written one language for a long time, you almost are unaware of how much of that is built into your mental model. It just feels like the way to do it. You don't really know where your mental model ends and the language begins until you try a different language.
True, and that's absolutely true. And at the end of the day, it's all in the code review, and the best thing that works is to make 2 novice Rust developers review each other's code, fight it off, and then you kind of like referee between them, and then suggest something after they reviewed each other's code to find even bigger, more fundamental things that might be missing simply because they're looking through the rose glasses of their specific language.
Do you find that the learning resources available are right for this mental model switch? I mean, the Rust book really kind of starts from hello world and basic concepts and builds up, but it seems like a very different task to take a well-schooled team in a specific language and just try to do this mental model transition.
I don't think there's a clear recipe transition. Like if you do this instead, especially like for different languages. I mean, you can kind of do this for like, for example, for Golang error model, because like you return success, okay, and error, and then like if error is not now, you return. And instead of that, this is how it translates, by the way, quite well into Rust's match statement versus the question mark. Overall, though, I don't see this as a very good approach. what I found works quite well is, first of all, the comprehensive Rust, awesome resource for teaching as lessons and great for both self-learning and as a teaching tool. But fundamentally, you need folks to start trying things, running into problems, and then learning how to fix those problems. In other words, you start with a problem. You don't start with just blank state and then try to learn as much as possible, because most of it will not apply to the problems that you may face. Rust space is humongous. From macros to embedded to various tricks with the functional language. I mean, there's a lot of stuff.
Yeah.
You don't want to dump all of that on someone on some poor soul coming from another language. You want to start with what they need to get their deliverables done, what issues they run into, because they'll hit all these issues eventually. Just focus on the ones they did hit and then explain how things should be solved. And that's why you need Q&A sessions and Rust Tigers, and that's where open office hour type of situations work quite well.
Tiger teams, I love it. Yeah. You know, one other topic I wanted to mention is open source software in automotive. And where are we at with the adoption of open source in automotive? What are the pain points there? How do we get more of that?
So, first of all, it's a bigger question in terms of it doesn't have to be only automotive. There's a bigger fundamental questions like how do we coexist between the corporate world, money world, and open source volunteer world. And those hopefully one day will have even better working relations because they realize they really need each other. So let's start with that. And my suggestion would be for the corporations to establish funds at the very top level where these are the funds dedicated to open source. I've actually seen that at Elastic working quite well. And that fund gets split up by the request of project managers who say, look, there's this tool, this library that's critical to our success. We need it to survive. We would lose much more if tomorrow the guy goes on vacation or the maintainer decides that she wants to,
go farming. Quit technology and become a farmer.
I was thinking more like focus on another project, but sure. So there's all these dependencies that are critical to success, and the project managers should be able to go into that fund and say, look, we would like to allocate it to this project. And the barrier of allocation should be as low as possible.
Yeah.
And that every company should realize that if they don't do it, guess what? Some other company might have different priorities for different dependencies, and their dependencies will survive, yours will not.
Yeah.
At the same time, open source developers, they need to prove they're not some drive-by forkers who just forked some code and pretend that it's a big deal and then tomorrow it's going to be gone. So you need to establish yourself as a serious open source contributor. One thing that Map Libre worked quite well with is Open Collective. There's this nonprofit that does all the paperwork, does all the relations building with the big corporations, and does the due diligence in terms of, does this project meets the open source requirements? Does it have a board? Does it have bylaws? Does it meet regularly? Does it actually do things that are more or less more open sourcey and in a proper way? So it vouches for the projects, and it functions as an umbrella organization for the open source. And these things work quite well. Now switching to automotive. There is so much more in automotive than just general open source little components, like I want my own serializer or something. With automotive, you have hardware. Hardware becomes much more difficult to test and maintain. SMD, for example, a very awesome project, maintains amazing library of code to support all the chips from Atmel now.
Yeah, that's the embedded HAL for like at SAMD21.
Right.
Yeah.
There's a lot of different chipsets they're supporting, and all that work allows anyone to onboard those chips very rapidly.
Yeah.
At the same time, folks like Infineon built amazing automotive standard safety, reliable chips, and yet they never built a community of open source developers maintaining this ecosystem of Rust code. And as a result, onboarding those chips, while everyone wants to, and Hightech, who is their compiler company, they built good compiler, but again, there's no ecosystem of tooling and libraries, so to onboard the chips very easily, you just get a big dump of compiler and some examples, and everyone is on their own. There's no community helping each other build these things.
Yeah.
And that's something that Hightech wants to do, and yet it requires both someone to set up the CI/CD so that it gets tested automatically. Developers who want to do it as an open source should get the free licenses for this. I mean, it's a work.
It's a big cultural and business shift.
Exactly.
Yeah. It's not trivial.
Right. So
Yeah.
everyone has to see the benefits. Like the automotive manufacturers should see, like, yes, we want to participate in this open source movement so that we all collaboratively build on something and we don't spend as much money. Because remember, it's a cost center for all these companies. It's not a benefit. It's not their secret sauce. Mm-hmm. It's just some fundamental building blocks which are almost identical in all these companies.
Yeah.
So they don't want to maintain it.
It's just infrastructure. It's non-differentiated. You just have to do it.
Exactly.
Yeah.
So the more you can shift to the open source, the better. And one hidden advantage to all this, guess what? All the open source code that I've seen tends to be much better quality than the closed source, because the very first thing I hear from someone asking them, like, can you open source it? They're like, no, I'm kind of ashamed of this code.
Yeah.
People don't feel confident about some of the code they write if no one sees them. But if that code is visible, all of a sudden there's much better quality, especially if it gets maintained.
Well, I think that there is, you mentioned onboarding the technology, but there's also onboarding the people. And there's a lot to be said for if the technologies that you're working with are developed in the open source, then when you go out to hire new engineers, they might have already worked directly with that stack and can hit the ground running. And I mean, I've been asked by developers who want to get into automotive, hey, what are some good open source projects I can contribute to learn the automotive development stack? And I'm always like, ooh, not many. Most of them are proprietary and expensive.
Right.
So, yeah.
I mean, well, Embassy is awesome. If good experience there. Some Embassy has some hardware to play with that they support out of the box. SMD is amazing as well. They took quite a few examples from Embassy and adopting that to SMD. There's a lot of open source developers in hardware in the embedded space, and they're very excited to help you and guide you.
Yeah.
And
you just need to let them. You just need to open the door.
And on top of that, the HAL project, for example, standardized quite a few of these things, and that's an amazing effort because then it standardizes hardware development across the different chipsets, across different embedded devices, and that's also a very important aspect.
Embedded HAL really showed up the right moment to allow everyone in the Rust embedded ecosystem to collaborate because it gave them that trait interface. So you mentioned something earlier that I do want to come back to, which is the funding model. So one of the things you mentioned is you're getting your organization to pre-allocate their open source spend in the budget and then figure out how they want to spend it. Instead of you saying, hey, I have this open source project I really like, but then you have to go get that allocated in the budget after the fact is much more difficult. So
and then you have to do the due diligence and prove that these people are not your friends that you're just trying to siphon the money through and whatever. It's a lot of work, and most managers do not want to deal with that, obviously, unless it's like some really big project that is extremely critical to their success.
Yeah. So pre-allocating, saying here's the amount of the budget, we'll find the right open source projects to go to, and then the other part of that is making sure that the projects are above board and they're doing things correctly. And I know that there's like the Cloud Native Computing Foundation, and obviously the Rust Foundation is getting into this.
Eclipse Foundation.
Eclipse is a big one. So is there something? Is there kind of the parent open source in automotive that is, the people that a company like Rivian or another OEM would look to and say, okay, if they're part of this consortium, they are a real open source project that we can contribute to?
So I have had quite a few contacts with the Eclipse consortium. Like Mercedes is trying to build some diagnostic tools in Rust, diagnostic ecosystem of Rust. There's vehicle efforts to create software-defined vehicles as a platform, although that's not part of the consortium as far as I know. I might be mistaken there.
It's open source, but I don't think it's part of Eclipse SDV.
Right.
Yeah.
Open Collective is much more generic. I don't think they focus on any specific. I don't think there's any inherent trust in them, but they do have well-established working relations with all the due diligence has been done basically by major corporations like Google, Microsoft, Facebook, Amazon. They all have done that. So if those companies want to fund, and there's many, many more that have worked with them, it's much easier for the managers, lower level managers, to just work out of their budget. But I don't know if many companies have established that as a separate budget. That aspect, then you kind of have one budget for both the contract work and the open source work. But fundamentally, it's different because open source work, very often you get to write it off because you're donating to a nonprofit. So you want to have it slightly going through different financial channels inside the company.
But in a weird way, it makes sense for it to be the same financial channel, because then you can say, hey, this software that we would have had to have paid a contractor to develop anyway, we can now pull from open source, so we might as well take that money that we were going to spend and give it to the open source.
I'll let the accountants deal with that.
That's fair, yeah.
That's outside of my area of expertise, but I'm sure there's some interesting things there.
Well, I mean, I think that is part of the justification of open source.
That is fair.
You need all the software anyway.
Right.
So, you're either going to have to do everything either in-house, proprietary, or work with contractors, or you can draw on open source.
Exactly, and it's a risk thing. You want the cheap software, but you want to de-risk it by investing into it, but you invest much less than you would have otherwise if you bought it, contracted for it, or other aspect of any kind of open source development is if you actually dedicate part of your funding towards your contribution of code rather than software to that project. This way, you build in-team knowledge of the project. You become experts in that project. You contribute to the project as well, but you contribute the code and fixes. At the same time, you have so much better understanding of the project and you use it more fully inside. That's what has happened with Map Libre, for example, because we have been using Map Libre rendering stack at Rivian and quite successfully. And we had a number of engineers work on making it possible and contributing back to the community while we're doing that.
Yeah, it's a very pivotal moment in automotive with all these SDV platforms coming out, and it feels like a moment where this could all be one common open source platform that everyone's contributing to, or it could be a bunch of proprietary.
Same car, everyone's producing exactly the same car with just different window tint.
Well, so for folks who don't know, Rivian kind of spun out the Rivian Volkswagen joint venture, which is now developing a software stack across two automotives. So, you more than many other people working in this industry are developing software for two different OEMs that will be a common architecture.
Yes.
Yeah.
Obviously, I cannot go into details.
Sure, I'm just going by the name of the company, right? That's as far as we're getting into the confidential stuff. It says two automakers on the outside of the building.
Right.
So, it sounds like a really exciting time to be in automotive. I know a lot of the Rust community is just very curious about automotive because it seems like it's such a good fit for Rust, and there's a lot more interest in correctness. So you're already kind of in that world of
and security. When you do an OTA, an over-the-air update, you really don't want to introduce some security vulnerability that someone just hacks your vehicle. There's a lot of other things that you want to stay as secure as possible, and Rust offers that too.
Yeah, and with upcoming cybersecurity regulations, especially in Europe, that's going to be a bigger and bigger factor in the conversation. Well, thank you so much for the time. I think, if you're watching this video before you've watched Yuri's talk, go watch Yuri's talk. It's a great set of lessons about not just Rust adoption in automotive, but Rust adoption in any large company with established practices and regulatory burden, and the exact kind of places that we want to see Rust and yet are sometimes the hardest to adopt. So Yuri, thank you so much for the time. Anything
you
want to plug, a personal website or Map Libre or an open source project?
I'm sure you'll have some at
We'll,
the end.
we'll put some links in, yeah. Cool. Thank you so much, Yuri.
Thank you.